So, this is it then. Make this into something. In fact, make it into this. I'm not saying it isn't tasteful, but doing it. Once they've made up their minds, that is. Come on, decide where you want to put the basin for my sake. Does it really have to be over there? Oh. Mind you, I have seen designs where the only way to fit the toilet in would be to hang it from the ceiling. No idea, some people. Are we all settled then? Right, let's get on with it. And whatever design you're dealing with, the only way to get a professional result is to make the right start. Now that makes things a lot clearer. And transferring the floor plan onto a diagram like this makes it very straightforward to work out the pipe runs. There's the 22mm handling the flow and return for the main central heating. A 10mm branch off that is all we'll require for the feed and return for the small radiator. And runs of 15mm tubing to carry the hot water to the basin and the cold to the basin and toilet. And laying it out like this allows us to plan the whole process of getting the bends and the joints absolutely right. We'll be using capillary fittings mostly, but wherever they may need to disconnect in the future, we'll put in a compression fitting. Now, the next move. We've planned it all out, so we can now see exactly how much tube and how many fittings we're going to need. Okay, so we just measure up and fill in the details. Simplifies it a lot doing a bit of pre-planning. So, we know how much tube we want and what fittings we need. Now it's just a case of fitting it all in. I mean, for example, we've got to get up to the radiator valve without driving ourselves round the bend. Oh, and look at this one. That's where they want the taps. Now we've got to make sure we get the tubing into the right place to meet them. The great beauty with copper tubing is that it's not only a pretty flexible material, but handle it the right way and you can make sure it ends up exactly where you need it. No problem. Like here, where we've got to plumb in the cistern. We need to get this 90-degree bend in just the right place in the tubing. Of course, simple really when you know how. And of course, we'll have a few joints when all this gets put together. Easy. Let's see, up to the radiator valve, that'll be a compression joint. And to get us there, we'll have a permanent capillary soldered joint. So, on with the job! Right, let's get going with this 15mm tube and the 90-degree bend to feed cold water to the loo. Pretty straightforward, this one, but it's always best to mark it up before you start bending, otherwise it could all go horribly wrong. And for this one, we'll use a bending spring. Easy enough to do. You just have to remember that there's what's known as gain in the material when you pull the bend. That is, the tube that's bent takes a short cut, and so there's some tube gained, and that depends on the angle of the bend and the diameter of the tube. As a general guideline, the radius of any bend should be 4 times the diameter of the tube you're using. So, once you've worked out where the bending point is, mark the tube, then you mark the start of the bend. That's 4 times the outside diameter back from your first mark. Okay? You following that all right? Good. Now all you've got to do is mark the end of the bending length. Then you insert the spring. Make sure it's the right size and not old and rusty. That'll save you a lot of problems. You bend the tube using your knee as the point of resistance. You need to pull the bend a little bit more than the final angle. That makes it easier to remove the spring when you pull the tube back to the angle you want. Just give it a little twist and out it comes. Twisting the spring simply reduces its diameter. Neat, isn't it? A word of warning. If you don't use the right spring or if you pull too tight, the bend can cause the tube to wrinkle. There you are, just as we planned it. There are all sorts of devices to help handle angles and offsets. A frame bender can take care of tube up to 42mm, and a handheld device like this can cope with anything up to 22mm. It'll handle the tube in this job very easily. And we'll need to bend this small bore 10mm tube. It'll run along from the main flow pipe and up to the radiator valve supplying the hot water from the heating system. Good thing about all these machines is they're easy to carry around, and you can make a lot of bends very quickly and make bends near to the end of the tube. All the time you can keep the same degree of accuracy. Let's take the bends in the hot and cold water feeds in the corner, for example. It's always important to mark up your tubing carefully before you start. To do this using a bender, you measure from the chosen end to the centre length and add half a tube diameter before you mark it up. You put the tube into the bender, put the back guide between the pressure roller and the tube, and make sure that your mark is lined up using a square. The square should touch the mark and the edge of the former. There, just pull the handle and a perfect bend. So that wasn't too difficult. Okay, let's have a go at something which is a bit more tricky, where you've got two aligned 90-degree bends. That's what we've got to do to get the water to the basin. Of course, copper protects any water supply totally. Heaven knows what some people keep in the cupboard under their basin, and your copper is impervious to the lot. Funny, even the ancient Egyptians knew that. If you've used one of these schematics when you've planned out your cloakroom, then you'll know that these two 90-degree bends aren't in the same plane. So even if you're making your tubes up off-site, you won't waste any material by bending them in the wrong direction. Now, what about measuring up for this job? Easy. Mark out and form the first bend just like before. Then for the second bend, use the centre-to-centre measurement for the pipe and mark up your new measuring point, adding half a tube width from the midpoint. Reposition your tube in the bender so that the bending point mark just aligns with the edge of the square and former. But before you do any bending, check out that it's on the right plane. See? It's quite simple, really. I tell you what does seem a bit dodgy, and that's doing the offset bends to get you to the taps themselves. No one's ever put taps in a convenient place like the edge of the basin, so we've got to get the tube to the tap. Still, it's easy when you know how. You use this kind of bend when you need to get round an obstacle or get to taps like these. What you do is find the angle of the bend by closing down a folding rule by the size of the offset. Then mark the centre of the bend on the tube. Put your tube in the machine so that the bending mark cuts across the angle of your staggered rule when it's touching the former, and then bend the tube until it's parallel with the rule. Now to form the second bend. Position the bent tube over a straight edge so that the offset size can be measured and marked. Finally, reposition your tube in the bender so that the mark aligns with the former edge and you bend until it's parallel. So, that's what you do for an offset bend. That's sorted it for the hot tap. Just a word of advice on machine bending in general. Take care with the roller pressure on the guide. Too loose and you can get nasty corrugations, not something anyone wants. If you put too much pressure on the roller, you'll make an oval tube, and you don't want that either. It's just a case of measuring accurately, positioning the tube correctly, and taking reasonable care when you tighten the screw on the pressure roller. Okay, so we've positioned all our tubes, bent them all correctly. What we've got to do now is join them up. You've probably noticed that you don't need many clips to support your copper tubes. That's because copper's quite rigid, and so you can install it vertically and horizontally without sagging. Good, isn't it? Back to the tube. Now, this one here, our flow pipe for the central heating, needs to be joined to our new pipe to the radiator valve. We'll use what's called a capillary T. It makes a permanent link between three sections of tube. Here's a capillary coupling which already has the right amount of solder inside the fitting, but we could have used the traditional end feed capillary fitting, which requires the solder to be added at both ends when the joint is made. What we do is make sure that the tube is cut square, and then we deburr the inside. That makes sure the water will flow properly once the system's up and running. Then we have to clean the tube and the fitting. You can use steel wool or emery cloth, but there are special abrasive pads made for this job which are even better. They don't leave any particles which might get into the system later on. Once you've cleaned everything, then you need to apply flux, only a small amount. This cleans the surface of the copper and allows the solder to make a strong bond between the surfaces. Don't get any flux inside the tube itself, only on the outer surface. Then you need to twist the fitting onto the tube and wipe off any excess. Now, use the blowtorch to apply an even heat to the fitting and the tube. With this sort of fitting, you don't need to apply any solder because it's already there. Once the heat's applied, the capillary action draws the solder around the joint. But if copper's able to resist very high temperatures, wallpaper and skirting boards can't, so make sure you protect them with a special heat mat. You know the joint's ready when you see a fillet of solder at the mouth of the fitting. When the joint's cooled down, wipe off any flux residue with a clean wet rag. If we made the same joint with an end feed fitting, it's simply a matter of heating the copper and feeding solder wire into the mouth of the fitting. Then once you can see the solder fillet at the mouth of the fitting, the joint is complete. There's no need to add any more. So let's have a look. We've still got to connect up the radiator valves. Now this is a joint which could be disconnected from time to time in the future, so we'll use what's known as a compression joint. In fact, this one's a non-manipulative compression joint. Just like the capillary joint, you must make sure that the tube is cut to the right length and remove any burrs, and make sure that the tube end is clean and free from any deep scores. Then you fully insert the tube into the fitting and make sure that the compression ring, or olive as it's sometimes called, is on the tube. The manufacturer's instructions will tell you how much you need to tighten the nut, which makes the olive grip the tube, just slightly compressing the flexible copper. It's this which forms the strong watertight seal. You'll know it's all secure if you can't rotate it by hand. So we've done it. Or at least we will have done it when we've flushed the system through and tested our joints under pressure. Working with copper isn't difficult, and with a little practice you can develop all the skills you need to deliver a really professional result which will be good for a lifetime. And that's important from everyone's point of view. Mind you, those who'll use this cloakroom will just assume that it's going to be totally reliable. I doubt very much they'll say to themselves, look at these 90-degree bends, now I do like that. And I don't think they'll take a look at the offsets under the taps, or give a thought to the fact that if you'd got that 90-degree bend wrong, the loo would have had to be somewhere in the middle of the garden to meet the cold water feed pipe. As for the capillary and compression joints, very neat pieces of work if they're done properly, but the customer probably thinks olives are what you get on the end of a stick at a cocktail party. Copper has been the professional's choice for more than 60 years, and there are some installations from way back still going strong. I've got to say it, I think it looks a picture, don't you? Brass Victorian taps, marbled walls, but look at that copper tube, it's something to be proud of. Well installed, and you know it's got quality. Once you've put it in, you'll not have to worry about it. They don't at the Bank of England. All their plumbing's copper, you know. Bet that's worth a bob or two. Lovely job.